Hello everyone, welcome back. And in this, I'm using the M0104 begin file, and I'm going to go to my rigging tab. By the way, if you want to change your workspace to look exactly like mine, I've made a little bit of a change. I keep getting an error message in my feedback line, so I've taken that out of there. But you can go to Workspaces and choose Reset Maya Classic to Factory Default, and then I like to go into Windows and change my UI elements and hide the command line for now. All right, so I'm going to go to rigging and I'm going to pull up the joint tool. Okay, I'll double click on the joint tool to bring up the tool settings, and basically for these I'm just going to reset. You should reset them to the default so that we're all working on the same page. I'm going to hit the joint tool and I'm going to hold down the X key and I'm going to click here, here, and here. If you're off a little bit, don't worry about it. I'm going to hit return, and now what I get in the outliner, I get joint 5, joint 6, and joint 7. They are in a hierarchical relationship, meaning that one is parented to the other, and you can see that here. I'm going to rename these. I'm going to rename this shoulder, elbow, and wrist. Okay, I'm going to do that because it's for ease of identification. All right, so basically what joints are is they are transform nodes that are deformers. Okay, they're a lot like locators, except they're much easier to operate in a hierarchy, but basically as far as locators go, they're always located in space in relation to the 0, 0, 0 point, or to the origin. Okay, so this one's at 0, 0, 0. Actually, take that back. It's not. The top of the chain is oriented in space. The next object is in the child object is in the local space of the parent. So in other words, it's translated 11 units on X. Even though it is at the 0, 0, 0 point, it's still translated 11 from X, and this is translated 11 from its parent. Okay, so that's an important point. It always maintains that relationship. If you go to modify and reset your transformations, nothing will happen. Okay, in order to reset it, you go to 0 and it will take it back to its parent. And you can put it back by typing 11. So that's something to keep in mind. These always maintain a relationship to its parent. Other thing that it has that you need to be aware of is rotational axes. Each of these rotational axes is in relation to its parent as well. For example, actually the rotational axes are pointing toward the child. All right, so what I'm going to do is I'm going to select each one of these joints, and I'm going to go to Display, Transform Display Local Rotation Axes, so that we can see what's happening. All right, so what's happening is X is pointing down the joint. If I go to my attribute editor, I will see that my rotate order is X, Y, Z, and when you create joints, that will be the joint that is pointing down the joint to the child. Except this end joint doesn't have a child, so its rotational axes are oriented the same as the world. Okay, and those rotational axes are important. Remember that they're there. Also know that you can adjust these rotation axes if you need to. And that's what a lot of rigging is involved with. So what I'm going to do now is I've got these joints, and I'm going to do the same thing here as I did before. But what I want to do now is I want to talk about another aspect of joints, and that's their size. There's a couple of ways you can change things, and it's a good idea to know this so that if you get into this situation, you won't have joints that are really too small or really too large. If I go to my animation preferences, I can change the size of all the joints in my file by changing my joint size here. Actually, so if I go to 1, they will all change. But every joint in all of my in every layer, for example, if I go back to my demo layer and go to those joints up here, these joints will change too. See how they're changing? They're getting larger and smaller as I change them. That may not be what you want. Okay, and by the way, this is display only. This has nothing to do with the actual function of the joint. All right, so instead, if I want to make that change, I can also make it from the attribute editor, but that's going to be on an individual joint basis, and the individual joint that's going to be changed is going to be the one that is green, or the last one that's selected. The easiest way to change a joint chain is to select the chain and then change the radius here. And that changes it just for this joint chain. All All right, so we've changed the size of this. We've talked about our local rotation axes. Now we're going to talk a little bit about what happens in the course of setting up a skeleton, which is what we're going to do in a succeeding clip. What happens if we change these after the fact? Okay. For example, if I were to go and create another joint chain, and I'll hold down the X key, and this time I'll go here and here. And now if, whoops, delete and hit return. Now if I select these, and you can see already what's happening here. My joints are, the rotational axes are basically mirroring this, except I'm going to go to display, transform display, local rotation axes. Except that now the X is pointing down the joint to the child here. Now what does that mean? Well, that means that we will have consistent rotations. So if I select these two joints, all right, if I select these two joints, joint 5 and joint 6, and I rotate them, they are going to flex the way one would expect, consistently. They'll do the same thing here, and more importantly, they'll twist properly. So if I grab this, and I'll rotate it, see how it rotates the way it should. All right, I'm going to go ahead and delete this. No, I'm not yet. I'm going to grab this joint here, and I'm going to move it into a semblance of, because it's much easier to move these than it is to rotate them into position. Basically, this is going to be almost the same orientation, but notice my local rotation axes didn't change. So that now if I click on this joint, and I rotate it, I will see that it does not rotate. It does not twist the way I would expect it. The good news is we can adjust these local rotation axes. For one thing, notice that there are no rotates on these because we've moved them into position. We haven't rotated them. So one way we can do this is we can manipulate the local rotation axes themselves. And this is a component of a joint. So I can go to my component selection mode, click on here and make sure that local rotation axes is selected. And I can click on this axis, click on this joint, select it, click on the axis and rotate it manually and line things up, and then go back here, and now it should rotate like we expect. However, rotating, it's not perfect. It isn't exact enough for our purposes. Rigging is a discipline where, quite frankly, a little inconsistency like this axis being off slightly earlier on in the process can result in disaster later on down the process. So we really want to do this. We want to make sure that our rotation axes are done exactly right. And there are a couple of ways to do that. I'm going to show you the aim constrained way, and then in the next clip I'm going to talk about the best way, which is to use a MEL script that's in wide use. Okay, so basically to use the aim constraint, we'll do this real quick. I'll aim constrain the forearm. All right, so I'm going to grab this particular joint and I'm going to unparent it using Shift P. I'm going to grab this particular, I'm going to grab my wrist, not wrist, I'm going to grab the elbow. Actually, I'm going to grab the wrist, and then I'm going to hold down the command key and grab the elbow, and I'm going to aim constrain. I'm going to go to constrain aim options. I'm going to bring this up, and I'm going to set this with the aim vector of 1, the up vector of y, and the world up type is y here. And I'm going to click apply. Okay, now what that does is that gives me, that vectors this joint and points it right at, and aims it at the child joint, the wrist joint. It also blues out my rotates, and that means that it is constrained. Good news is I can delete that constraint, and I still get the same effect. But I have rotational values in this elbow joint. Okay, so I don't want that. I want those zeroed out. But if I zero them out, which I can do, if I zero them out, boom, whoops, hit the wrong, then it goes back to the way it was. I don't want that. So what I'm going to do is I'm going to take these rotational values and I'm going to put them in my joint orient field. Hit return. Yep, it doubles that. It doubles those changes But then when I zero this out, it's correct. Okay, so I'm going to then parent it up, and I'm good to go. Okay, so we've manually did the shoulder. We did the aim constraint here. In the next movie, I'm going to show you how to use what's called Comet Joint Orient, which is the gold standard for doing this type of thing.